Okay, so we are seeing people are already joining in. Welcome
Yes.
everyone on the third session of this Tezos online hackathon, Tez India. I'll just talk a little bit of for 1 minute until we see more people coming, and maybe then I'll give a brief introduction of Cryptonomic. Then Mike, maybe you could tell just a little bit, even though you told yesterday about the team and yourself. So we can just do a 1 or 2 minute interactive talk, and then we'll move ahead to the Tezos 101. So, guys, this is Tez India Karappa Hackathon brought to you by Tez India Foundation, and we are in the third session of webinar. This is Tezos 101. So, still now we have had Blockchain 101, where you got a chance to know about what is blockchain, basics of blockchain. Then we have tools that we have, and this session is specifically about Tezos 101, where Mike from Cryptonomic is going to take you through the elements of Tezos, the architecture of Tezos, and how to the Tezos journey. So, Cryptonomic is a New York-based team, and they've been building decentralized solution, and they've been in the Tezos ecosystem since the very beginning. They have built some great tools on top of Tezos, like they have Galleon wallet, which is widely used Tezos wallet. They have Explorers, Aeronex. They have the entire tool suite in Nautilus Cloud, and they have libraries, Consul.js, and indexers. So they have a pretty foolproof suite to start any kind of development on top of Tezos. But that is just I'm giving you, and Mike will tell you better about how to find your way around Tezos and how to build amazing apps, or how to deploy smart contracts, and how to get to find a way around Tezos using Cryptonomic stack, and So, Mike, over to you. Thank you very much for being here. Thank you very much for taking this session. I know this early here there in New York. Thanks for being here again. Thank you. Over to you, Mike.
It's 10:30 in the morning, which I agree is a little bit too early for me to be forming full sentences, and I'm about 1 cup of coffee in, so this should be okay. Right, so I'm Mike from Cryptonomic. I do have something about us, the team, what we do later in the deck. For now, let's just assume that I know stuff about blockchains. I'm going to present about Tezos, but also some motivation that created Tezos, let's say, something that inspired the need for Tezos to exist in the first place. So let me share my screen so you can see my deck. Right, so my name is Mike. I like that name because it makes me anonymous in most rooms. It's a popular name, and in blockchains, anonymity is a thing, so that worked out quite well. I'm very excited to be presenting to you guys. I really appreciate the opportunity that Tezos India has given us to do this for you. And yes, I'm from Cryptonomic. We build a bunch of tools for Tezos, and we will cover that in a bit. But first, let's talk about blockchains. So a lot of people think about blockchains as money. This is true to some extent, but there is a technical reason why this is the case. So on a fundamental level, all public chains create a store of value, and we'll discuss why this is required. But blockchains, if you think about them as digital money, they're not really very different from a bank account, because bank accounts are already electronic. We might use credit cards, ATM cards, and our money is tangible to the extent that you see a number on the screen. Another important thing to to remember is that blockchains are not specifically synonymous with cryptocurrency, and we'll cover that as well. So why did we get to blockchains in the first place? At some point, I guess some few years, over a decade ago, there was an interest in distribution of power. There was a significant credit event in the markets. Economies across the world collapsed or suffered anyway, and we ended up with Bitcoin. And then we got a bunch of other stuff. So on its own, as a system, Bitcoin is pretty amazing. It creates a decentralized system for distribution of value. I can transact with other participants in the chain without trust. And this is amazing. This was not possible before. Previously, generally speaking, you require trust, unless, of course, you take cash and you bring it to someone, in which case there's still a possibility that you get robbed, but in any case. So Bitcoin is the first popular blockchain, and a couple of things about it. It has a very, very simple partitioning resolution scheme. What I mean by that is if there is an ephemeral fork, the longest chain wins, and that's it. A lot of people say that blockchains are intrinsically anonymous. This is definitely not true of Bitcoin. I had a conversation recently at a similar event, and someone suggested that we can hide our identities on platforms like Bitcoin. But my response to that is, if anything, your transactions on Bitcoin create a permanent, immutable record of you potentially breaking the law. So keep that in mind. And the last thing is that Bitcoin has a capped supply, which is not strictly true of all other blockchains. So I said earlier that blockchains are not cryptocurrency. And that's true, but a lot of blockchains do have cryptocurrency associated with them. So why is that? Well, public chains had to overcome a challenge, a security challenge specifically. And to do so, blockchains have special participants. On Bitcoin, they're called miners. On Tezos, they're called something else. We'll get to that. And these miners effectively provide security for the chain. So to incentivize them to provide the service to the community, they're paid. And they're paid in cryptocurrency. This allows a blockchain to be correct in an adversarial environment. This is what makes it decentralized. Now, Bitcoin has a proof of work consensus mechanism, which is not particularly efficient. You might have heard some ridiculous metrics like the Bitcoin platform takes up as much electricity per year as some country, and which country it is depends on the year, and the amount of energy it uses keeps going up. I think Switzerland might have been the most recent one that I heard. Another thing is Bitcoin is susceptible to 51% of tax. What that means is if you control a large enough section of the network, meaning that if you control enough miners, enough computing power, you can decide what the truth actually is on the chain. But despite all these things, one reason why a lot of people think that blockchains are secure is that we haven't yet had a hack. There was no explicit demonstration that the system does not actually work. so far, something like 12 years later, Bitcoin is quite safe. So then we got Ethereum. Bitcoin was interesting, and in a rudimentary sense, it's programmable money because there's a way for you to associate a script with your balance. But Ethereum created something new on top of it. They said, well, we'd like to have a Turing-complete programming language, and this effectively allows you to develop any kind of an application on the blockchain. It is still proof of work, although for several years now they have been working on the effort to move it to proof of stake system. Tezos, incidentally, is also a proof of stake system, but they work in different ways. Once Ethereum actually has a working proof of stake system. So let's talk a bit more about other blockchain aspects. There's this concept of finality. Well, once a transaction is recorded on a chain, what does that really mean? How can you be certain that you're not on a fork that may get resolved in a different way than what you're expecting? So finality is a metric to determine that. So if you trade on some popular exchanges, for example, in America, we use Coinbase quite a bit, and they consider finality to be quite long. On Tezos, from what I hear, they wait for 60 blocks, meaning that if I execute a transaction right now, Coinbase will not consider it as committed for nearly an hour, or about an hour. Other chains have other mechanisms for finality. Other exchanges, of course, take different approaches to this, but yeah. Now, another thing is cost of participation. So there are different kinds of participants on blockchains. For example, two people can transact balances, or someone can run a miner, or someone can run a validator in the context of proof of stake chains. But these things have a cost. So there's generally a fee associated with a transaction. So if I want to send someone some coins, I would pay a transaction fee. If I would like to run a miner, this requires electricity cost, hardware cost, and so forth. Let's see what else. Transaction throughput is another thing people talk about that's important. So how many transactions per unit time can a blockchain execute? So a lot of people like to compare this to like the Visa payment network, which I don't think is appropriate at the moment. I don't even think it's necessarily required. Blockchains don't need to be successful in order to be able to do, I don't know, 1 billion transactions a day or whatever Visa claims to do. Probably not 1 billion, but a high number anyway. When we think about interbank transfers instead, which are larger balances, but they're less frequent. This is already a system that's quite useful and quite popular, and blockchains can support a system of this nature already. Finally, hard forks. So Ethereum, incidentally, is a good example. There are multiple popular Ethereum chains, even though they are the same underlying technology. And that brings us to Tezos. So also a smart contract platform with a Turing-complete programming language. It is a proof of stake system. Specifically, it is liquid proof of stake. This is a very interesting and different method of consensus compared to other chains. And it democratizes chain participation in a sense. We'll cover that in a moment. And finally, another interesting feature of Tezos is on-chain governance. On-chain governance is a mechanism by which special participants, validators, Tezos calls them bakers. They call them bakers because I think Tezos came from a French team, and the French are famous for their breads, so bakers. bakers vote on proposals. Proposals are submitted by really anyone on the chain can submit a proposal for a change to the platform, and the proposal consists of a hash of a piece of code, and then this code is provided somewhere else so that it can be validated and run. And then bakers will vote on whether or not this new code should be included in the platform, and that's governance. But let's talk about proof of stake in this context a little bit more. Blockchains create value every single block as a security mechanism that we mentioned before. So miners on Bitcoin, if they get lucky, they mine a block and they get a large reward. Now there are mining pools that distribute this reward amongst multiple people and so on. On Tezos, the distribution of rewards is a system feature. So the way it works is the following. A baker can offer a delegation service. What that means is smaller platform participants. So let's say, for example, that I have, 500 Tez. And 500 Tez is not enough for me to be a baker, for me to run a validation, which means that I would miss out on these delegation, on the rewards that the platform creates every cycle. So what I can do is I can delegate my balance to a baker. And at the moment, there's effectively a social contract in place. It says that if I delegate my balance to a baker, this baker will share their rewards with me after they take a cut that would cover their costs. So if a baker has electricity costs, hardware costs, and so on, so they will keep some of the reward and distribute my share to me. So when I said earlier about the fact that it democratizes participation, is that it allows anyone to, let's say, financially benefit from being on this blockchain. So even with a small balance, you can delegate to a baker and you will get a reward every cycle. So the details are mildly complicated. There are a lot of conditions on which you get paid and how long it takes and so on. I think ultimately they're not really important in this context. I can certainly address questions if anyone has any questions, and we're available in various chat rooms as well. But in any case, this is exciting because anyone can now participate. So as long as you hold a balance and you delegate it to a baker, you will get a reward. There are baker rating services. One of the other technology teams participating in this hackathon, Baking Bad, those guys run a spectacular baker rating service. You guys should check it out. Right. So this also ties into this on-chain governance. So a baker will vote on a proposal. When they vote, the weight of their vote is their staked balance. And their staked balance is their own balance and the balance of all the people who are delegating to them. So this encourages a social participation in the platform where if I have an opinion about a proposal, let's say I'm a programmer, I looked at the code and I have input that I can then communicate to my baker and say, look, I think you should vote yes because of this, or I think you should vote no because of something else. And this is quite interesting. Now, another important difference between proof of stake on Tezos versus other chains is the holder never releases control of their funds. So the process of delegation does not involve me sending my funds to the baker. The delegation process simply says, it's a record that says, Mike has assigned his delegation rights to this baker. But if I spend this money, if I spend these tokens today, they're still under my control. I can do this immediately. Furthermore, I can change my baker at will anytime. Again, there are some conditions on how quickly your baker changes actually takes effect and so on. But the key point here is that the delegator always controls their tokens, always. Other chains have a lockout period and so on. Not the case here. And another interesting thing also related to democratization is after the fundraiser period, once the chain went live, it took only 15 cycles for the platform to become under control of the general public, well, the rest of the participants, meaning that the foundation, Tezos Foundation obviously ran bakers, and they still do. In 15 cycles, more than half the bakers were not foundation bakers, and this is very exciting. Right. Oh, one last point about bakers. There are lots of them, hundreds actually, and the fact that there's so many bakers also contributes to security of the platform. If you compare this to other proof-of-stake chains, they have below dozens of validator nodes. In the case of Tezos, to hundreds. And this number, of course, fluctuates. People come and go. Excellent. There are other examples of blockchains, though. So I said earlier that blockchains are not synonymous with cryptocurrency, and it's absolutely true. So you don't need cryptocurrency in an environment where trust exists. So between companies who already have agreements, or between banks, for example, or perhaps shipping companies that are already working together, there's not a specific need to confirm that they're being honest, because you assume that they're already honest. It's in everyone's best interest on these private chains to be honest with each other, because they already are in a symbiotic business relationship anyway. So these kinds of chains do not have cryptocurrency. There's no need for it. You don't need to incentivize your miners or your validators to be honest, because they of course are already. And there are several examples of technologies for this. Quorum from JP Morgan is one. It's actually a fork of Ethereum. There's also Hyperledger Fabric and so on. Centralized chains. So a piece of this deck is a little old. This particular slide came from some months ago when Facebook's Libra was in the news. So, personal opinion, just my opinion, I don't think Libra is going to work. I don't see how centralized chain controlled by a for-profit company can succeed in the regulatory environment. I could be wrong. Centralized chains, at least in the context of Libra, the way I interpret it is it's not particularly useful to the participants. It's more or less a gift card system. I don't see any reason why I would rather use, let's say, something like Libra as opposed to something like Tezos or Ethereum, whether it's for smart contract development or value transfer. But in any case, all this stuff with smart contracts allows us to create applications. And when you think about developing applications on blockchains, don't think about just dApps in the sense that, yes, they may be dApps because they are interacting with the blockchain, but there should be a reason why you chose to build an application on a blockchain. So you have to take a whole product approach to why you decided to use this particular technology. And there could be great reasons why. But my point is that don't simply build on blockchains because, ooh, blockchains. Let's not do that. So what kinds of applications have been built? So again, I do think it's too soon for broadly adopted payment systems. Blockchains are simply not fast enough. Finality is not soon enough, and so on. There are solutions to these problems, which are side chains and second layer things and so on. But I feel like they take away from the core premise of a blockchain, where It is supposed to be public, decentralized, and trustless, and side chains don't always offer that. We have seen functional applications already for settlement systems. So I mentioned earlier interbank transfers. So things of that nature where you have a relatively small number of transactions between a relatively small number of participants. And they're great for this. And there are reasons why. So for example, if there's a network of banks and there's a large but bounded number of banks in the world, let's say it's 50,000 banks. 50,000 accounts is not an enormous number. So if all these 50,000 banks decide to participate in a particular chain, perhaps a consortium chain, not one necessarily open to the public, they would gain benefit from running this network in a decentralized fashion because it reduces technology complexity in some ways. So there are lots of great but perhaps boring reasons why blockchains work in certain applications. Asset tokenization is another thing. It's very exciting. We recently added support for tokens to our stack. Very cool stuff. So tokenization, we could talk about that in more detail if you'd like, but effectively it's a way for you to collect investment from a broad collection of people for a particular asset. In normal finance, it's called securitization. So things like IPOs and so on. And finally, data provenance also has been an interesting application that we've seen in various places where you would like to have a public but secure record of a thing like land ownership. Recently, I've had discussions about storing public book publication information on the blockchain as well. So things like that. Cool. What can we build with this stuff? So as Cryptonomic, we've spent quite some time building the tools to help us realize the vision, if you will, for interesting applications that we can build on blockchains. And I feel like we've done enough of that where now we're really thinking more about building on blockchains as opposed to for blockchains. So as much as, of course, we continue to develop our tools and we continue to add functionality in that respect, but we're also starting to build applications that use a blockchain to provide value to customers as opposed to just simply building tools to help developers use blockchains. And that's one exciting thing for us here is we'll be able to use our, show you how to use our tools to allow you to build your product instead of thinking about details of blockchain implementations that are not necessary for your product to be successful. So challenges. That slide's very true. Blockchains are not super easy to use. So we've spent a lot of time building our tools with the experience of using our tools to build products. So if you looked at our stack, we have a bunch of things like Kansei, the blockchain index of Kansei.js, which is a front-end library, some other stuff. Our products like AaronX and Galleon are built on top of these libraries and services. So all the lessons that we've learned from trying to build these applications, we've poured into our tools so that the next set of developers who use them will benefit from it and find it easier. And for that matter, we're constantly taking in feedback from developers. Let's see. Week boundaries are a little bit off for me right now because we've been in this coronavirus-related lockdown. So I just realized it's Monday. I was going to say just this week, but this week just started. So let's say over the last several days, I made 2 updates to Kansei.js to address specific needs of a couple of different developers. So we are very interested in your feedback. So if something is still difficult for you with Kansei.js or Kansei and so on, please tell us. So there are lots of other things in the blockchain space beyond Tezos, and you should definitely look and learn from them as well. Zcash is a different and interesting thing. Polkadot is worth looking at as well. So that's my presentation on Tezos. I can tell you a little bit about our stuff, or I can take some questions and tell you about our stuff later. Omo, what do you think?
Yeah, so guys, if you have any questions, like I see one question, who decides which baker can bake the block? I mean, if you guys have any question about the baking or governance of Theos architecture as in general, you can ask that. They only have one question till now, but guys, keep your question ready.
Okay, so how is a baker decided? There are some details to this, but at a high level, what happens is seven cycles ahead, a process runs on the blockchain to identify all possible bakers. And then there is a pseudo-random process that says, okay, well, you're going to bake, you're going to bake, you're going to bake, you're going to bake. And they're assigned quite a while in advance. And there is a provision there as well for a baker failing to make a block. So what happens is, right now, at 11:01 in New York, there would be already a record for someone who's going to bake a block in a week. And if they fail to bake a block, there's going to be another person behind them. And if they fail, there's again one person behind them. And I believe it's 64 slots per block. There's also endorsements. So there are actually two things that bakers do. They bake blocks and they endorse blocks. An endorsement is basically saying, yes, I agree that the previous block is indeed valid. And bakers collect endorsement rewards as well.
So we have another question, which is, can you please elaborate on delegated proof of stake?
Okay, so what it means is, in order to receive rewards on a blockchain, generally you need to be a special participant like a miner or a validator, a baker. But on Tezos, they have delegation. And delegation allows small holders, or for that matter, large holders who simply don't want to run a baking operation. It allows any participant to delegate their stake to a baker. And what that does is it increases the stake of the baker you delegated to. So by extension, they now get to bake more blocks. I should have mentioned this earlier. So the number of blocks a particular baker gets to make depends on the size of their stake. And of course, if they misbehave, a piece of their stake is lost. And sometimes distributed, for that matter, to people who accuse them of being naughty, if you will. So yes, what delegated proof of stake allows is broader participation in the validation process, and allows more people to collect rewards from. You're on mute. You're on mute.
Oh, sorry. So one question we have is Ethereum versus Tezos. It's just Ethereum versus Tezos question. And the second is how transactions take place on Tezos. Whichever you like. Answer.
Okay. So Ethereum versus Tezos, I like things I can use today. I am less excited about promises. So Tezos is a proof of stake system you can use today. It has these interesting voting features, interesting delegation features. It has a full-fledged smart contract language. I'm excited about that. Can you use Ethereum? Yes. I do not like the fact that Ethereum is proof of work, public Ethereum anyway. Would I use private Ethereum? Yes, I think that has great applications as well. But Tezos, if you're specifically interested in developing on public chains, I do think Tezos is a better platform to target. Now, Tezos has not been around publicly as long, if you will. So the tools are still being built and so forth. But the community is very engaged. So if you need help, if you come across a problem, people will help you. And what was the other question? How do transactions happen? I'm not sure exactly how to address that, but so Tezos has several kinds of operations. One of those operations is a transaction. A transaction can again be of two types. It can either be a simple balance transfer between two accounts, or it can be a contract invocation. A transaction directed at a KT1 address on Tezos smart contracts have KT1 addresses. Will have potentially parameters, and this smart contract will collect those parameters and then execute. Otherwise, it works in similar ways in the sense that there is gas, although gas behaves slightly differently than it does in Ethereum. There's gas, there's storage cost, there is a transaction fee that the bakers will keep for including a transaction in the block. There are certain restrictions. So, for example, if you are executing a contract, it must fit within a block. At the moment, the maximum block gas is, I think, 1.1 million units. That's quite significant. Yeah.
Okay. Guys, if anybody wants to ask any more questions, you can tell us now, or we're going to move ahead.
Well, I also have a bunch of slides about our stack, so you guys can think about your questions while looking at my screenshots.
Yes.
So let me do that.
Okay, let's go ahead.
So I believe Vishak used some of these words, was it yesterday, a couple of days ago at the intro call. These are the fancy things we aspire to do. Yes. So we have built tools and we've helped people build applications that enable these things on blockchains and specifically on Tezos. So let's cover some of them. We are in Bushwick in Brooklyn. It's a very hipster neighborhood, so we're quite a startup, I would say, very in line with expectation as far as popular culture goes. We have our neighbors down the block is a cement plant, and 2 blocks down there is a sausage factory, so very startup. At the same time, we have broad experience in financial systems. I worked in corporate finance, for example, for quite a while. Some of the other people have too. We have a requisite PhD on the team as well. My primary contribution is Snark, which is why I do presentations. So as I said earlier, we have been building for blockchains and more recently on blockchains. And I like to think that the value we bring as a company to this space is discipline. We've, over the years, built, deployed, and supported large distributed applications in the context of corporate finance. And these are complex systems that must be on all the time and behave in predictable ways. And we bring this experience with us to blockchains. On the non-technical side, we've been building communities. We host these workshops, we have meetups, we engage with the community in other ways. And of course, we're building tools. So let's talk about the things that we've built specifically for Tezos. This is Galleon. If you've used Tezos before, probably used our wallet. This is actually the upcoming release. A couple of exciting things there. We have token support. This is new and interesting. Can't wait. We have Mininex. Mininex is a traditional block explorer, if that's the thing. So effectively, it allows you to look up an operation or an account on a blockchain, and it gives you various attributes of that account. This is a screenshot I created this morning, apparently at just before 1 in the morning. Aranex. So this is interesting. Aranex is not a block explorer. It is a data analytics and reporting tool for blockchains. It is chain agnostic, but this deployment is for Tezos. So an important difference between Aranex and Mininex is that Aranex allows you to ask more general questions. Mininex can do a lookup of a hash. So you give it a hash and it says, oh, this hash is an operation. Here's what happened in that operation. With Aranex, you can do that. But Aranex allows you to do things like, what are the top 10 most active smart contracts in the last month? And Aranex can do that for you. Where you can say, well, in this case, I was curious about why smart contract invocations fail. So I said, give me all operations since March 5th that failed, and give me the reason why they failed, and give me the smart contract that was invoked along with the parameters that were sent into it. So you can do this kind of stuff. Now, these things are useful in multiple ways. So for one, you can run financial style reports on these things. You can see who the largest participants on the chain are. You can see who is transacting the most, or the least for that matter. You can see average size of a transfer and so on. But also, you can do technical things like, well, my contract invocation failed. Can I find a smart contract similar to mine and see how they use it, for example? So that's been quite useful. Now, as I said before, we have been building these things for a while and learning lessons for our own products. And based on that, we built Nautilus Cloud, which I hope you guys will be using as you build your applications on Tezos for this hackathon. This is a hosted blockchain solution. I would not advise you to run your own nodes. Running nodes is a complex, time-sucking task. So we have infrastructure, of course, that supports our products, like the wallet and the various block explorers. So we are making this available to other people. So you would sign up with your GitHub account, and you'll get presented API keys that you can use both in production and in development. And this is infrastructure that we make available to you. And in addition to having access to Tezos blockchain nodes, you get access to Consei. And the Consei, as you use it through Consei.js, allows you to do the stuff that I just described about Aranex. So you can, for example, easily extract all operations for a particular account, or you can get all contract invocations against a smart contract and so on. So Consei service is available for you to use through Consei.js here. So these are the things that we hope you check out. All this stuff is open source. You can take a look at our GitHub repo, submit issues, and provide comments if you haven't. These are the libraries that this stuff is all built on top of. So Consei is a modular chain indexing solution. It pulls new blocks, processes them into a database so that we can then query them efficiently. Ultimately, blockchains are linked lists. Linked lists don't render themselves easily to simple queries that you might have to do. So for example, I said earlier, how do you know who has your account ever transacted with? Well, ordinarily you would have to start from the Genesis block to the current head and figure out like, oh, did I transact in this block or not? Well, Consei indexes this information for it. Consei yes is a library in TypeScript, so you can use it for Node, you can use it in the web. We have a minified release of it. You can use it, of course, in React and so on, to build applications. So the wallet, Aranex, Mininex all use this for the technical component of this workshop in a couple of days. I will walk you through using Tezos in this context. And if you're interested, we also have ReasonML bindings for Tezos. And that's it. This is actually everything I have for you guys. So now I'll take any questions you might have. Thank you.
Thank you very much, Mike, for this session. So, okay, guys, you can keep your questions ready. I see there are already some questions there from the last time for Tezos. You can keep posting questions, guys, and we'll answer them one by one. So the first question that we got, Mike, was during the Tezos presentation. Apart from Baker, there were terms such as accuser, upgrader, endorser. Can you throw some light on these as well? This was
so let's see. Bakers perform two operations. Bakers create blocks, and they also endorse blocks. So if I'm Baker at time 0 and Ohm is a Baker t+1, what that means is I will create a block, and then Ohm will look at it and say, oh yeah, I validated the operations in this block and the end result is correct. So he will give me a check. There are, I believe, 32 endorsement slots per block, and a block, you would like to include the block in a chain that has a high number of endorsements. At the same time, if Ohm decides that my block is somehow invalid, perhaps I'm cheating or I simply did something wrong, he can accuse me of producing a bad block. Now, when an accusation happens, if it's confirmed, I get my funds slashed. So this is the proof of stake piece, right? So I stake some balance to say, yes, I promise to be honest. And if I'm not honest, you can take away my balance. It's not quite so drastic. The amount of balance taken away is not all of it, of course, it's less. But yes, if I create a bad block, I will get slashed. Ohm is going to receive some of the of my balance as a reward, and I, technically speaking, should not be baking for the rest of the cycle.
okay. So next question is from Heisenberg about how transaction throughput can be increased in Tezos apart from side chains.
Well, let's see. The last protocol upgrade cartridge that was deployed just recently increased the gas limit for the block. In some sense, increasing the gas limit increases transaction throughput because it allows more transactions to be included in a single block. Block time on Tezos is already fairly short. It's about 60 seconds. I mean, I think it's technically actually somewhat less, but a block is expected to be recorded about every 60 seconds. So I don't think we're at a point right now where increasing transaction throughput is a thing we need to worry about, but there are definitely paths towards doing this.
Okay. Next question is where we can see transaction logs.
So I'm not sure what that means exactly, but what you can do is you can open Aranex, you can go to the operations tab, and that has a preset filter for transactions. So there's an important, I guess, verbal distinction between transactions and operations. An operation operations are all of the kinds of things that can happen on a chain, and there are 12 or 13 kinds of them. A transaction is one kind. So a transaction, as I said before, can either be a contract invocation or a balance transfer. But there's also an endorsement operation. There is a double baking accusation operation. There are all sorts of operations. But if you're simply interested in transactions, open Aranex, look around.
Next question is, I guess, sort of a Council J's doubt. I think you can post that, Aditya, you can post that in the Cryptonomic channel, and there, I guess, that would be the best way to answer that. It's Council J's issue. Next question is, what is gossip network and ghost network? And then it says, when we deploy some application on testnet, say Carthen is the application deployed locally?
Okay, so nodes do talk amongst themselves to synchronize state on the gossip network. It's a peer-to-peer protocol to distribute information between nodes. So, for example, when you use Tezos-dev to submit a transaction, our nodes will communicate to other nodes in the chain saying, hey, we received this operation from the user. So then a baker node will eventually also get that synced up and say, okay, I'm going to include this operation. When you deploy CarthageNet, no. So we deploy directly to the public test chain, meaning that if you deploy to CarthageNet, I will be able to see your deployment. I will be able to interact with the smart contract. I'll be able to see the source code of the smart contract. There are efforts to run Tezos in a sandbox where you can have a node that is only yours and it's local. Tulip Tools comes to mind. I can give you guys a link in the chat if you're interested. But there are ways to do that. But no, when you deploy through Tezos to CarthageNet, it goes to the public test chain.
Okay, so if there are any more questions, guys, you can ask right now. Okay. So so I'll just give a brief overview of what's going to happen next is. Until then, maybe if you want to write question, you can type that. So this was a session to introduce you guys with Tezos 101 and the Cryptonomic tech stack. And day after tomorrow, we are going to have a live hands-on interactive session about how to interact with the tools of the Cryptonomic tech stack. And they also have bounties. So what's going to happen is, let's say you could also get bounties from both sides, like you are getting the hackathon bounty, and if you build a specific application in the set format using Cryptonomic tech, then you might get double bounties. So that is also something very exciting for you. So that session is going to happen day after tomorrow. And if you have a question, please share the link which can guide us to Tezos tag development. So I think the Vishak has shared some links in the Cryptonomic channel. You can look at there, and there is also going to be one session day after tomorrow where you can also get to know about smart contract development and deployment of Tezos tag development. Right. So Mike, if you can just give an overview of just like a minute or something, or seconds about the session of day after tomorrow.
Yeah, sure.
Okay.
So actually, it would be exactly addressing the last question in the chat. So we're going to cover the functionality of Consay and Consay.js. So we're going to do some hands-on coding in JavaScript or TypeScript. I mean, I have code samples in TypeScript I will share with you guys. I will help you set up your development environments with Node. And we'll run through some scenarios for common usages of the network. And once we get through that, the second part is about smart contract development. We'll be looking at smart contract samples in SmartPy. Quite usable, nice development environment for smart contracts and Tezos.
Okay, thank you. I guess there's no more questions. So thank you very much, Mike, for this wonderful session. I hope all of you guys, all of the participants, it's a great insight to go over today and tomorrow. You have a lot of time, and let's keep building. Let's if you have any question, you can ask them in Cryptonomic Discord channel, or you can there also, if you have any question about other things, such as explorers or wallets or something, they also have Mike has also shared the Riot channel where they are pretty active. So bunch of they are active on various social media channels. Wherever you are active, you guys can interact there, and you can keep asking a question. Aditya, the question that you have asked, which is like constant query, you can ask that in the channel, and they will help you out. So Again, thank you very much, Mike, for being here for in such an early time and giving this one.
My pleasure. Thanks for having me. And I guess I'll see you guys in a couple of days.
Yeah, sure, day after tomorrow. Okay, guys, thank you very much. With this, we'll end this session, and we are going to have this recording with us. We are going to share in 1 or 2 days. So if you want to go over from something from the beginning, you can go over always. And we're also going to have a recording for other sessions that we had done till now. Thank you, guys. Thank you very much. Thank you, Mike. Thank you, Vishal. Thank you, Cryptonomic. Thank you, all of us. See you guys.
Thanks.
Bye.